Subject name is compiler design. Today we are going to discuss about the topic that is called as storage organization and storage allocation strategies. How storage can be implemented and in the process of compiler design. What are the various methods, strategies that is available in this? Now, the compiler generally the compiler it expect some amount of memory that is called as block of memory for the operating system which the program has been executed. So here generally the program instructions which are available in that phase can be implemented with the help of different phases goes through the execution of different phases. But each time, whenever it enters into the phase, each of the phases, it expects some amount of memory from the operating system point of view also. So that's why this block of memory, whenever the a compiler goes for executing the compiled program, whenever program is execution takes place, this amount of memory can be expected, and this storage is called as runtime storage organization. Runtime storage organization. This is called as runtime storage organization. This is divided. This runtime storage organization here it is divided into several parts such as generating the target code, data objects, and control. Runtime storage is divided into three parts. That is generated target code, data objects, and stack, control stack together. Now, here, whenever the size of the target code is fixed at compile time, then compiler can place statically determined one. So here, size of the data objects may also be known at compile time. Compile time referring evaluating some amount of code, and that is and the runtime target code that is to be evaluated at some. So some of the objects may be determined size of the objects at compile time, and some of the objects may be determined at runtime. So what are the objects which are determined at compile time? That is, it is determined at, and this determined statically. That is called as compile time determination. Whereas runtime determination, that is dynamic. So here diagram is showing that a typical diagram which shows that the code, data, stack, and heap. Now here code is nothing but the program which is to be executed differently for purposes with the help of several instructions. Now what is the data that is available? That is to be determined, that static data that is compiled time, and runtime some of the memory is divided into code and data areas. So here what is the data areas here? Static data and stack heap. Now these areas, whatever the data that is to be available, heap comes from this end and stack data comes from this end. So both are to be grown, that is enlarged as per the requirements, as per the size of the program instruction execution. It keep on expanding the things from each of the sides so that it generates the execution code dynamically at runtime. That is how the runtime storage division takes place with the help of the target code, data objects, and stack. Here target code, data objects, and stack. A target code is this one, target code, data objects, and then stack. So here the stack is to be used for the purpose of activating the procedures, and previous session we have discussed about how the procedure activation takes place and how whenever it enters into that and then leaving the corresponding execution status. Here we told that a stack is used generally for the purpose of managing the activation procedures. That means we are going to define a procedure name, and followed by list that begin and end statements. Begin, list of statements, and end. Now the activation of the procedures, that is the activations each time takes place, it is to be called each and every time. That is calling the procedure, deactivating the procedure. Whenever the call happens, the activation of the procedure takes place, and then the list of the statements, and after completion of the procedure execution, it returns the control to the place where it is exactly called. So it returns that result. Then completes that means execution stops for that procedure. So all these activation of the procedures, that means execution of the procedure activation. Sometimes within the procedure we may call another routines or subroutines also. So that is called as interruption mechanism. Interruption mechanism indicates that at certain point we are going to raise the at certain sequence. So statement 1, statement 2, statement 3, like this there will be list of statements. So out of this, may at any point you may call the subroutine a task, and you may activate this subroutine, that is called as activation interruption. That means this is a separate call. Once again go to the stack. That means suppose for example statement 1, statement 2, statement 3, like this within the procedure begin end. Maybe procedure 1 which contains this list of statement. Now this contains any statement which contains call to another subroutine, sub-procedure, another subroutine. So this is to be stored inside a procedure. Activation takes place from the stack, and whenever subroutine procedure also may activate another, so this is also called takes place. So while interaction in between procedure 1 and sub procedure 2, so definitely there will be an activation interrupts, and then that activation of that sub procedure can be informed through the status of the stack. That means what is the program counter value and what are the machine registers till now, what is the values that are to be available, that is to be updated onto the stack, and then the control returns to the call. Then control returns to the call where it actually our procedure is to be invoked. So this type of things that is to be happened. That means control is returns from the call. Previous procedure is suspend activation. That means suppose here procedure statement 1, statement 2, statement 3. So here this is the begin and end of the procedure. So you may call that is a sub procedure. It is a for example sub procedure activated. Now here the sub procedure calls to the sub procedure is to be invoked with another one. Now what happens? The suspension that is previous procedure, that means up to statement 1 it is executed. Now this is suspended. That means statement 3 is suspended for a period of time until it resumes the sub procedure with the values with the corresponding registers, that is machine registers and program counter values, and then resumes with the call with the statement 3 next after resumes. That means Procedure 1 is to be stored inside the stack with the contents of the mission and mission registers and counter values, and sub-procedure also contains this mission registers and program counter values. But whenever the call happen, that means invocation call occurs to the execution of the procedure, it executes all the list of statements one by one, but it stops whenever the activation of the another procedure occurs. Then it interrupts the actual procedure which is to be executed, and then comes to that part where it is exactly, that is, then subroutine procedure is invoked with the corresponding results, and then go to this. So like this, it is to be maintained with the result, and then the proper execution of the each of the procedure one by one takes place. So simply where the execution is stopped, it resumes that call once again where it is actually suspended, and then resumes the call. After that, it storing the corresponding values, and relevant register information also can be updated onto the stack. And sometimes the lifetime of activations also need to be maintained. So, but that is not able to represent with the help of this activation tree. But we can use the activations information. So, what are the information that is to be used? So, that is what is the activations of previous call, and after suspending, resuming the call, then you might be lost some of the data objects or regain the control of some of the data. So that information is to be up to date, keep on to be maintained, but that is to be how the information, that type of information can be used. So here that is that type of data that is called as allocation of data items. Say for example, data object 1 is to be allocated with some value. So after resume the procedure is resumed. That means previously it is suspended and resume with some other call. That means here how the data object, what is the value of the data object 1, this may be updated. So here we are going to use that mechanism is called as heap mechanism instead of stack. But here stack we are going to use allocation as well as deallocation. So these purposes we are going to, that is each time a procedure is called, that is to be maintained as a data inside the stack. But while coming to the data objects, each and every time whether it is updating the corresponding registers or not, then generally we will use a mechanism called as heap mechanism, heap data structures. We can also use stack, but compared to stack, heap provides the dynamic storage of data results. So that's why here we are going to use a heap data structure. And also the size of the stack and heap, the sizes of both stack and heap will be going to changes as per the needs of the program instructions. Whenever the program is executed, then this side stack contents one side, and the other end, that is heap contents. In the previous diagram also we have seen. So this type of data structures, that is to be data is to be available. So this to be growing towards each other as per the required. Oppositely, the stack side this side and the heap side this. So whenever the required, that means data objects one more and less spaces, depends on the constraint of the program instruction, data objects requirement, it will be enlarged or end towards this side and this side positive and towards both ends, and then it grows each other. So this type of storage organization is available in case of, that is compiler storage structure, where each and every time the procedure is to be activations, deactivations, suspending call, resume the previous procedure, like that. So here we know that the storage occupies some amount of memory at runtime. But what is the information, actual information that is required for single execution of the procedure. Suppose we are taking one procedure and we call that procedure, and one time it is executed. So what is the actual contents? What are the different points, blocks that are available inside the storage organization? So this is called as activation record of a activation record or frame. That means it consists of several fields. So we know, as per the diagram, we can say this is the activation record. In this activation record, several fields. One is return value, one field, first field. Another field, actual parameters, optional control link, optional access link, and a saved mission status, local data, and temporaries. That means each time procedure is activated, at that time some amount of memory execution takes place. That means some block of storage. So this is maintained with the help of an activation record which contains fields or frames. That record is to be contains various various fields of information. That information such as return value. That means whenever we are going to brief overview about what are the different fields which are available in this one. Now, first one is if you take temporary values. So here temporaries is the one. We are going to write different temporaries whenever the expression is out. Say for example, a equal to b plus c plus d. Now we are going to write a temporary t1 equal to b plus c, then a equal to t1 plus d. So here we used a temporary that is called as T1. See here we are going to use a T1 number. So like that for one instruction we have been used for a program, there will be a lot of temporary values. These we are going to use for the evaluation of expression. So these are to be stored in the field that is called as temporary. There is a field called temporary is the field. In this field all the relevant information which is required whenever the expression is to be created with the help of. So, for one expression, we may use another T1. May it contains T1, T2, T3, like that. Different temporaries are to be used for the purpose of evaluating the expression. So, that is to be important. And the other one is local data. Here, data, whenever a procedure is to be written with the help of some variables, that means taking the arguments. So that arguments are to be considered as local to the procedure. So procedure 1, local data which holds some data that is local to particular procedure. While it is so procedure 1 which executes some data that is argument 1, argument 2. That means in the A comma B, this procedure contains values equal. So may be used inside that begin statement. We may use that is int c equal to a plus b end. But here the c value which is local, c that is local to this procedure, So this c value, the variable c which is local to this procedure. So that is taken care by this local data which holds that data. Like that different data items may be used inside the procedure. That is to be considered as, so here this is to be maintain all the list of local variables which are available for that one can be applicable used as local. So that is the one of the important field which is used for the purpose of that. Another one is saved mission status. So this is called as saved mission status. That means whenever information which contains the program, that is a procedure before, that means before some statements are the statement 1, statement 2, like this statement there, then procedure occurs. So before the procedure is called, before the procedure, and after this, these are the steps after the procedure. Now before procedure execution, these are the statement. Before procedure, these are the statements. Now, what are the statements? What is the status of the data objects before a procedure is to be called? Before a procedure is called, what are the status, and program. That means here what are the values as per that, that is program counter and machine registers. Program counter PC and machine registers that have to be stored, and when control returns from the procedure. That means before calling the procedure, some of the data objects may be remained, and it returns with the corresponding program status and control values. That is to be maintained by the program counter. Now this is to be comes with some result before starting this procedure. After starting the procedure, once again regaining the control of the data objects with that procedure, with the data which is available inside that procedure, and then the updating, that means it also includes some other data which is available, and then that values also stored inside the program counter and machine register, and once again restored the control returns where the procedure execution happens. So this data is to be saved, all this information, that is called as saved machine status. Saved machine status. Before calling the procedure, data objects information, and then execution of the procedure, once again restoring the contents of program counters and machine registers. So those information that is to be the information that is to be available in the field, that is called as the saved machine register status. Saved machine status. So machine means here machine registers. It maintains some separate registers. Machine registers which are available to take care of the data objects which are available. That variables information pass through the several registers, updating, restoring the things with the help of program counter. So that is to be saved and holds that particular type of information in a particular field, that is called as saved machine status. Now that is one of the field that is to be contained in the activation record. Like this, there will be, we note that the three fields are to be discussed. One is temporary local data and saved machine. Two more fields is optional access link and optional control link. Optional access link is nothing but this is the field which is to be used. What is the data that is non-local to be non-local data, for which is that is held in other activation records. That means non-local data which is held in other activation. So here we have maintained activation data with some relevant information. So this is activation record 1. Maybe another record which may contain activation record 2, which also contains a different set of data objects. Now, what is the data, local data that is to be available in the activation record? And this information can be passed with the help of this parameter that is called as optional access link. Then you can access the data which is referring to the non-local data. That means here what is the data that is here available in data that is available in AR1, activation record 1, that is local. Whereas data that is available in AR2, that is non-local. That means it can access to the contents which are available and referring to the data that is available in another activation record. And then optional control link, another parameter. So here whenever the call comes from the activation record, it points to that particular, the control is placed to that corresponding procedure activation. So it points to the activation record of the caller whenever call comes. And another one is actual parameters and then return values. We know that actual parameters are the parameters which are passed to this procedure. That means whenever call, that is procedure with parameters, argument 1, argument 2, like this, that means this m comma n. So this procedural argument actual parameters, these are used by the calling procedure in order to supply that is parameters inside to the calling procedure. So calling procedure with some list of parameters and called procedure with some list of parameters. So that is to be whenever invocation happens, the calling procedure occurs, then automatically the procedure is matched with the parameter, that is formal parameter. So here two parameters, actual and formals. So previous session we discussed about some of the parameters that is called as actual parameters and formal. Now these actual parameters are to be confined with the formal parameters. If both are matched, that means here the data is available with the help of the different informations. Yes, then it is actual match occurs, then the called procedure completes the corresponding rules. So this is for example procedure m comma n. Then the called procedure that is begin with some list of statements n. Now you may return one more procedure with I comma j. Now once again this procedure invokes the corresponding procedure with the list of parameters map with the actual with the formal, that is m with I with m and j with n. So that means calling procedure and supplied parameters with the called procedure. Both of them the corresponding returns are result. That means after completion procedure definitely returns some result. So this return information is called as called procedure returning the value to the calling procedure. So procedure requires the data object, that is calculations. That calculation result is to be final result can be evaluated and then comes with the result where the procedure is stopped activation. So that is called as the suspend, that is resumes of this corresponding procedure. So simply procedure is invoked, this procedure invocation with the result. So m comma n. So this procedure is invocation with the result. So this return maybe it contains integer. So this return type returns return value. So this procedure return value that is to be maintained with some parameter that is called as return value. So that is first one, and this type of information is to be maintained each and every for each of the field record. In case of activation, that is activation record, that is called as activation record, or we can say that it is a frame where the parameters are to be accepted with the help of actual parameters field and returns with the values. Function returns some value and then access the optional control link. That means here local data which is to be available, and then any non-local data which is available in the other activation record can be accessed with the optional access link, and saved mission status with the help of several program counter and mission registers updated each and every time. Data that is available to the procedure, local data, and what are the temporaries differently that is used for the expressions, that is to be used for the expression. So like this we can store different values, fields of the information for each of the activation. So these are called as fields of activation record. And we are having several allocation strategies also. One is static allocation. Here static allocation we are going to store the data objects at compile time. That means storage for all the data objects at compile time only. And runtime heap allocation, that is allocates and deallocates storage as needed at runtime, and this area is known as heap area. That means that is called as heap allocation. Reallocation storage at runtime from the data area, it is known as heap area. Now static allocation here. What is the static allocation here? That what is the storage that is available in case of static allocation? Whenever the program is compiled, automatically some amount of memory, that is expecting some sort of memory, at compile time. That storage, it is bounding the storage whenever the program is compiled. It is called as static allocation. And here runtime supporting of the package is not required. And here we cannot change the runtime manipulations or anything, but every time procedure is activated. So here we are calling the procedure every time. Then definitely the name is bound to the corresponding storage locations. For example, procedure 1 with the help of some record, procedure 2 with some other storage record info. So what is the names that are available as per this, and what are the names available for procedure 2? So this is to be bound to what are the names which are bound to the procedure 1, and what are the names that are bound to the procedure 2 names for the corresponding storage location. Is it referring the same storage location or different storage location? That is to be resolved with the help of this methods. That is, local names are retained across activation of a procedure. In our name resolvement previously also we have seen how the environment static allocation with the names bounding mapping, the things can be done. We have seen with the help of a diagram also. Now whenever completes the procedure, that means the control comes back with the help with the result. That means returning the procedure. Then that values are local to the same whenever the control comes with the, that means left with the last time, where the control is left with the last one. That means procedure 1, procedure with one result, and the control after execution this statement, the control comes to the same place where it comes with the result. So this is that value which is available before and comes to this after execution can be local to the same. Is it local to the same where it is executed with the last time? So that is static allocation of binding names with the help of this procedure activations and compilations. The in the stack allocation, previous one is static allocation, now stack allocation. Here the control stack is divided into that is, one is activation record information, that is whenever the activation is procedure activation takes place, that is to be inserted, and whenever it completes it popped out from the stack. So that is called as activation of procedure begin. Procedure call means activation of procedure begin, and whenever procedure is completed, then end of the procedure. So beginning and end of the procedure. Begin procedure, and when it takes place means when it control comes to the particular procedure, the particular instruction, then beginning of the instruction, that is procedure takes place and completes end of the instruction. End of the instruction takes place. Here the storage. What is the storage for the locals in each of a procedure? That is to be contained in the activation record. Each of the procedure with the help of activation record for that call. And what is the variables that is to be available? That is local to this storage location each time the activation takes place. And a new activation record is to be pushed onto the stack whenever, that means different procedures, procedure 1, procedure 2, like this, procedure 3, each time activation takes place. So that is to be available new activation record. Suppose procedure 1 is completed, then control goes to the second procedure, procedure 2. So each time a new activation that is to be pushed onto the stack. So here stack contains procedure 1, it completes that information and returns the results. Next second, the control goes to the procedure 2, then it enters into the once again new activation record. So again activation record is to be pushed onto the stack, means again activation record contains fields, all the fields previously which you have discussed, that is stack parameters, return value, option access link, control link, temporaries, and all the data fields which are available, that is local data, everything that is to be mission status, all the things can be, fields can be maintained whenever the first time activation record is created. All the fields are to be maintained with the help of activation record, and then it is pushed onto the stack whenever the call is made. Call is made in the sense here it lots of information that is to be available. Some of the time the values which are local, that is to be available at particular certain amount of period whenever the procedure is in execution. Suppose after completion of say procedure 1 which contains some data, and this data is to be available until procedure is in execution. Once the procedure stops execution of the procedure, stops execution of a procedure, then automatically the values that is to be are previously available are lost. Values are lost automatically whenever the control comes back to this original position where the procedure is to be called, and it deletes the data objects which are available, which are local to that particular procedure, and then the information which are available that is local will be disappeared automatically. That means information is lost. There is no data where the activation record is popped. That means from the control stack, the activation record is popped from the stack, and then it can delete from the stack. So in this way, the stack control, stack activations, and data information that is to be stored for each of the records information. And another one is calling sequences. Here the procedure is to be called each and every time whenever call happens, and then the activation record of the particular stack with the fields of the information, each time different information fields are to be entered, and then it returns after execution of the procedure. That is to be sequence consists of, that is here, code sequence. It is a code sequence of statements where the activation record enters automatically and fields of the information is to be maintained. Once it is to be entered and goes through the sequence of execution, then control after completion, it returns the sequence. That means some result it is to be retained, and then it stays the status. What is the where the previous mission status is how much before calling, and after compiling, that is procedure activation, then what is the mission status, that is that called as state of a machine can be restored with the help of this calling procedure, and then continue the execution after the call. That means the control goes to the place where it is resumed, suspended, then it goes to the same place where it is done, and then that result is to be carried out with the remaining steps of the instruction. So this calling sequence is to be is called as, one is called a caller and another one is calling. That means activation of the procedure where it is to be activated. That means calling procedure, and second one is calling procedure. So here where the procedure is divided into two calls. One is caller and another one is calling. Called procedure and calling. So invoked procedure, and where the procedure is invoked, and then where the procedure is called. That means actual parameters and formal parameters. Then each of the procedure are to be takes place with the help of the result and returns with the control with the some result, and this return sequence is again restored with the mission status. Variable length data on stack. Another topic that is which is available in the stack content notation, memory management, runtime. Every time the allocation of procedures and data objects, size of the data object, they are maybe vary from one to another. So at compile time, it may not generally predict that things. Sometimes the stack contents and heap contents may shrink at that time. So some of them information which are local to the procedure and they are automatically allocated in SIMs and we are predictable. But sometimes we may not know. So that is for known as dynamic. That is called variable length data, which is available, where we have to avoid that type of garbage collections of the space. So that means several times repeatedly storing the data objects which are not required necessarily for execution can keep on maintaining a garbage collection of this one and the update of this space. And that space can be utilized for the procedures where the activations to the local to the procedure which is available and the parameters of the calls. That means they definitely it have the limit on the size of the calls, and this may reach an extra. Then we have to eliminate. We have to regain some of the space by applying the garbage collection methods, and we have to avoid generally this type of expense of garbage collections by. So this is called as dangling references. That means generally procedure is completes the process of execution, then we have to deallocate from that storage. So if not, if the by chance, if any by chance, if that data object it is not deallocated at particular point of time, that means this is a reference to the storage that is being allocated. So generally sometimes errors may occur during this one, that is called as logical error. A logical error is used, logical error to use dangling references. And that means suppose if you are declared int A, and this may use and not defined sometimes at particular point, and some of the programming languages may use some restriction how to define that particular data objects and where it is to be used, and some of the programming languages there is no restriction to use that one, no need to mention that the declaration part. So for that case the that is to be carried out some storage space unknowingly, and later the allocation of these objects at any point of time may take some storage space. Then that is that causes to the bugs, chance of errors, and these errors are called as a logical errors and makes use of this dangling reference. That means it is a reference, dangling reference. That means it is a reference to the unused objects, unused data objects. That means previously data objects may be available that is used for the program instruction part of the procedure, but at certain point of time, that means after completing the procedure, procedure ends, procedure ends, then the data objects which are local to that one can be eliminated and removed. But by chance if they are remain, then that by chance if that data object is remained inside that storage organization, then there is a chance of referring that unused objects. So chance of referencing the unused objects. So that reference is called as dangling references. Then that reference is called as dangling. That means there is a chance. So we have to use this storage organization as a specific purpose, and deallocations doesn't happen, then problem of dangling references may arises. There is a chance of arising the dangling references whenever if the deallocations are not properly done, not properly done, then there is a chance of getting this dangling reference. So the one time you have to take care of referencing that one, where the used objects, unused objects, and all the references to be clearly mentioned. And if not, then we have to apply the garbage collection methods for the separate for the corresponding programming languages. And then heap allocation is also available. We know that the extending the both stack and heap to maintain that is variable length data, and sometimes it is not possible to use for the local names heap data which is available, where the local names of the data and retaining of the activation records. That means here sometimes the data objects which are local to the specific procedure, and retaining that means after activation ends, then the data objects definitely lost the storage. So we have to regain once again. If you are trying to regain the control of that one for that local object, then it is very difficult to use the heap allocation process. And also outlives the color deactivation takes place. Called activation outlives, that is also a special case. And also some of the space which are the continuous storage space where occurs where the data objects can be maintained with the help of several records. And these deallocations and over the time heap may contains a different other alternative also to find the free space, and then once again use a reusage of that record deactivation record data items. So it maintains a different structure of the notation, and definitely it is useful for the variable length data of the records. All the contents which are discussed in this can be available from the compiler's principles and techniques. And so here we'll stop this one. Second, next we'll come up with one more topic that is uh, another new topic from this subject, compiler design. Okay, thank you once again. Thank you all of you.
Like, share, and subscribe. Hit the bell icon for more updates.